Jai Hind all. The topic which we are going to discuss today is TCP for wireless networks, and it comes under mobile computing with the subject code KCA 051. The contents which I am going to discuss today is introduction, then influences of mobility on TCP, classical TCP improvements, and the references. So this is basically a 5-layer TCP IP model, and you people are aware of this TCP IP model. On the layer 1, that is the below, on the bottom, we are having physical layer, and the various we are having Ethernet physical layer, ISDN modems, PLC, WiMAX, etc. on the physical layer. Then comes the data link layer, and there we are having 802.11 protocol, ATM, DTM, Ethernet, frame relay, etc. On the internet, then comes the internet layer. There we are having IP version 4 and version 6 protocols, IGMP, ICMP, ARP, and so on. Above that, we are having the transport layer, and in this transport layer, we are having TCP protocol, UDP protocol, DCCP protocol, etc. And the topmost layer is your application layer. And there we are having various protocols, for example, FTP, DNS, Gopher, Telnet. All these protocols, they are operating on the application layer. Now we are more concerned towards the fourth layer, that is transport layer, and that too on the TCP protocol. So transport layer, basically it sits between the application and the network layers. And the network layer, that is, it provides basic addressing and routing services. And in this case, there is no guarantee of delivery, ordering, or the duplicate removal. Whereas in the case of the wireless environment, we require that we cannot afford the misorders and the packet loss in the wireless environment. Transport layer, where there we are having UDP and TCP, it provides other basic services which is needed by the application, that is delivery to process rather than host in this case. And for this, we use the port numbers. For transmission, the transport layer protocol must keep track of what data comes from each application, then combine this data into a single flow and of data to send to the lower layers, splitting the data and tunneling it to the appropriate recipient process. And for this, it is responsible for dividing potentially large amount of data into segments. Then error checking is done here, that is error detection fields, or you could say checksums, is present in the headers. So in all, TCP provides connection oriented, reliable, full duplex and byte stream features. What is the meaning of connection oriented? Connection oriented means that a virtual connection is to be established before the communication begins. If the connection is not established, then the user program is notified and no communication takes place. If the connection is ever interrupted, then again the user program got notification and again no further communication would take place. It is a reliable protocol, and what the reliability means here? It means that every transmission of data is acknowledged by the receiver. That is, as soon as the receiver receives the data, it will send the acknowledgement to the sender. Now, if sender does not receive the acknowledgement within a stipulated amount of time, then it will retransmit the data. Byte stream, it means that the connection is treated as a stream of bytes, and the user application does not need to package the data in individual datagrams, which is being done in the UDP. In the UDP, we create the datagrams. Buffering, TCP is responsible for buffering the data and determining when it is the time to send a datagram. It is possible for an application to tell TCP to send the data if it has buffered without waiting for a buffer to fill up. It is a full duplex protocol, that is, it provides a transfer in both the directions. To the application program, these appear as two unrelated data streams. Although TCP can piggyback control and data communication by providing control information, for example, acknowledgement, that is ACK, along with the user data. Now, what is the influence of mobility on the TCP? TCP is already existing in the wired environment, but if we use TCP is in its original format, then it won't work in the wireless environment. While a slow start is one of the TCP protocol, while a slow start is one of the most useful mechanism in fixed network, it won't work in the mobility because it is not efficient protocol. TCP assumes congestion if the packets are dropped, typically wrong in wireless environment. Here we often have a packet loss due to transmission errors, maybe due to some delays or due to other network features. The packet might get dropped. Furthermore, mobility itself can cause the packet loss. For example, the mobile node is in the roaming state and it is connected to one of the access point, and the data is routed to the access point, but then that particular mobile node, it got connected to other access point, that is your foreign agent in that case. So now the packet is transmitted to the wrong access point and the forwarding is not possible if we use TCP in its original form. The performance of an unchanged TCP degrades severely. However, TCP cannot be changed fundamentally due to a large base of installation in the fixed network. So, the TCP for mobility has to remain compatible. That is, we need to make certain changes in the already existing TCP protocol to make it compatible with the mobile or wireless environment. The basic TCP mechanisms keep the whole internet together. That is the reason we cannot change the TCP protocol, the basic TCP protocol, for just the wireless environment. So these are the few classical TCP improvements in the case of mobile TCP. Indirect TCP, which is also known by the name I-TCP, snooping TCP, mobile TCP, which is known by the name M-TCP, fast retransmit or fast recovery, transmission or timeout freezing, selective retransmission, transaction-oriented TCP, that is T-TCP protocols. So, we will discuss all these improvements one by one for the mobile environment. First one is indirect TCP. TCP performs poorly with the wireless links, and TCP within the fixed network cannot be changed. So these are the two factors which have to be looked upon. Due to above problems, I-TCP is developed. In the case of I-TCP, it segments a TCP connection into fixed and wireless part. That is, it will divide your connection into two parts. One is for the fixed environment and another is for wireless environment. Access point, that is foreign agent, which is also known by the foreign agent in this case, is used as the segmentation point. Standard TCP is used into the fixed part and modified TCP is used for the wireless part. If you look at this figure, in the case of the indirect TCP, we are having a foreign agent here. This is the foreign agent, or you could say it is a breakpoint. Here we are having wireless communication. So we are having a wireless TCP. Here we are having a wired internet. So your standard TCP protocol would work here. Standard TCP is used in the fixed and modified TCP is used for the wireless. FA controls the mobility of MH and also hand over the connection to the next FA. That is, your FA stands for foreign agent and MH stands for your mobile handset. CN is your, in the fixed network, does not notice the wireless link. That is, in this case, this is my FA, this is my MH and this is my CN. FA acts as a proxy and relays the data in both the direction. Here, the FA is responsible for relaying the things in this as well as in this direction. Now what happens if CN sends a packet? The FA acknowledge this packet and forward this packet to MN. That is, CN is sending some data in this direction. Now what the FA will do? It will send the ACK on the behalf of the mobile host. And after sending the acknowledgement, it will send the packet in this wireless environment. Now, if a packet is lost in the wireless link due to some error, CN is not aware about it. Now, who will resend the data? FA. FA will transmit to maintain the reliable data transport. If MN sends the packet, FA acknowledges this and forwards it to CN. Packet loss in in wired network is again handled by the FA. So if you look at this particular figure, we are having TCP in both the cases. Here we are having FA. This is for TCP for the wired environment, and this is the TCP for wireless environment. So if MN sends the packet to CN, then FA will receive it. It will send the acknowledgement and resend the packet to the CN. Once the CN, it receives the packet, it will send the acknowledgement to the FA. And if it wants to send some data to MN, it will send that data to FA. FA will send the acknowledgement to the TCP on the behalf of MN or MH and propagate this packet in the wireless environment. Once the mobile host receives the packet, it will send the acknowledgement to the FA, and this is how the whole communication would finish. So here, what happened in the case of indirect or I-TCP? If the mobile host moves from one access point to another access point. Let's suppose this is the already established connection. This is your FA1 and this is your FA2. Now your mobile node, it moves from FA2 to FA1, that is, it has moved to this. Now this is the already existing communication link. So in the case of the migration, the state transfer, all these information will be updated to the CN by FA2, and now when the next time CN sends the data, it will send the data to FA1 and not to the FA2. So what are the advantages of I-TCP? No changes in fixed network is required. No changes for the host. Transmission errors on the wireless link do not got reflected in the fixed environment. Simple to control. Mobile TCP is only used for one hop between example of foreign agent and the mobile host. Therefore, a very fast retransmission of packet is possible because all the retransmission of packet is being done at the FA. But it is having its own disadvantages also. One of the drawback is the segmentation of single TCP connection into the two. This loses the original end-to-end TCP semantics, because we are aware TCP says end-to-end communication, but in this case, since FA is involved, so the communication is like from MH to FA and FA to CN. An acknowledgement to a sender does not any longer mean that the receiver has received the packet. And what happens if the foreign agent crash? Then in that case, the whole system would come to a halt. Another important variant is snooping TCP. In this case of FA, snooping TCP, FA buffers all the packets sent to the MN and snoops the packet flow in both the directions to recognizes the acknowledgement. To remain transparent, FA does not acknowledge the source until it gets the acknowledgement from the destination. That is, in the case of snooping TCP, what is happening? Here we are having end-to-end TCP connection. This is the wired environment and this is the, you could say, the wireless environment. So in this case, the communication, the packet is being transferred from mobile host to the CN, that is your corresponding node, but the foreign agent, it is snooping the packets for the acknowledgement and it is keeping a buffer. Lost packets on the wireless link will be retransmitted immediately by the mobile host or foreign agent respectively. So this is called as local retransmission. That is, retransmission is again happening at the foreign agent. Now the packet flow. What happens if the packet flow is from CN to MN? End-to-end TCP communication is there and foreign agent is here. So the CN will send the packet, FA will snoop the packet. It doesn't find that this is the data packet and it is not a acknowledgement packet. It will retransmit the packet to mobile node. Now mobile node will send the acknowledgement to FA. It will again snoop the acknowledgement packet and it comes to know, okay, MN has received the packet, and it will send the acknowledgement to CN. Now what happens if the packet does not received by the MN? Then in that case, the packet is lost in this environment, that is the wireless environment, and the MN does not send the acknowledgement packet. Now immediately FA comes to know that the acknowledgement has not been received after some specific amount of time, and it will assume that the packet has been lost in the wireless environment. So what will happen? It will retransmit the packet which it has already buffered and send the packet to the MN, and this is a local transmission. Now once the MN receives the packet, it will send the acknowledgement, and this acknowledgement is got received by the CN. Now what's the benefit of this acknowledgement packet being snooped at the FA is that once the FA received the acknowledgement, then it will not buffer the packet, because now it will assume the packet has been received by the MN. Now what happens if the packet flow is from MN to CN? Now the packet, MN will send the packet and it will received by the CN. Now for example, in this case, the CN once received a particular group of packet, then it is sending the acknowledgement. It will send the acknowledgement and this acknowledgement is being received by the MN. Now what happens if the MN is sending the packet and this packet got lost? So a gap is detected by the FA and it will send the not acknowledgement, that is NAC information to the MN and also send that which particular packet number has been lost. Now the MN node will retransmit that particular packet to the CN, and in this way the CN will receive all the packets which has been sent by the MN, and it will send a acknowledgement to the MN node. This is very much similar to the slow start cumulative algorithm. So in this case, data transferred to the mobile host, that is FA to MH. FA buffers the data until it receives the acknowledgement of the MH. FA detects the packet loss via duplicated acknowledgements or timeout. Fast retransmission is possible, transparent for the fixed network. Data transmission from mobile host, that is MH to FA. FA detects the packet loss on the wireless link via sequence numbers, via answers directly with a NAC to the MH. MH can now retransmit data only with only a very short delay. Advantages: it maintains end-to-end semantics in this case. Another variant is mobile TCP. It is a spatial handling of lengthy and or frequent, specially designed for handling lengthy and or frequent disconnections. MTCP splits as I-TCP does. Unmodified TCP fixed network to supervisory host SH connection. Now we have optimized TCP SH to MH. SH is responsible for exchanging the data between both parts, similar to the I-TCP. That is, instead of FA, what we are having SH in the case of mobile TCP. SH does not perform cache or retransmission of data via SH. If packet is lost in wireless link, the sender retransmit it. What's the role of SH? That is supervisory host. No caching, no retransmission is being done, as we have seen in the case of FA. It monitors all the packets. If the disconnection detected, it set the sender window size to 0. Now the sender automatically goes into the persistent mode. SH reopen the window to the old value as soon as the connection is live. The sender, after this, the sender can continue sending at full speed. What are the advantages? It maintains TCP end-to-end semantics. The SH does not send any acknowledgement by itself. It only forwards the acknowledgement. It supports the disconnection. If MH got disconnected, it avoids the retransmission, and the slow start algorithm just shrink. In this case, the window sizes shrink to 0. No buffering. Loss of packet will be automatically retransmitted to the new SH. But the disadvantage, SH does not acting as a proxy, therefore loss on the wireless link in this case propagate to the fixed network. It will affect the wired environment also. Another important protocol is fast retransmit or fast recovery protocol. In this case, change of foreign agent, that is FA, often results in packet loss. That is, if the mobile node is in roaming. Now TCP reacts with a slow start, although there is no congestion. In this case, we are having forced fast retransmit. That is, as soon as the mobile host has registered with a new FA, the MH sends the duplicate acknowledgements on purpose. This forces fast retransmit node at the communication partners. Additionally, the TCP on the MH is forced to continue sending with the actual window size and not to go into slow start after registration. And the advantages is simple changes result in significant higher performance. Another algo is another modification is a transmission or timeout freezing. In this case, mobile host can be disconnected for a longer time. Then what will happen? No packet exchange is possible. In this case, in a tunnel, disconnection due to overloaded cells of multiplexing with high priority traffic, TCP disconnects after timeout completely. In this case, we will go for the TCP freezing. What it says, MAC layer is often able to detect the interruption in advance. MAC can inform the TCP layer of upcoming loss of connection, and after this information, TCP stops sending but does now not assume a congested link. And as soon as the reconnection happens, then again MAC layer sends the information signal to the TCP layer, and TCP layer can assume can start sending the data at the same window size. Advantage is scheme is independent of data in this case. But the disadvantage, TCP on mobile host has to be changed in this case, because now we have to incorporate the communication between the MAC layer and the TCP. In the case of the another important protocol, modification is selective retransmission. TCP acknowledgements are often cumulative in nature. That is AKGEC. It acknowledges correct and in sequence receipt of packets up to n. If single packet are missing, quite often a whole packet sequence beginning at the gap has to be retransmitted. That is go back n algorithm, which you people have already seen in the wired environment. Thus, in this case, wasting the bandwidth. Now, since bandwidth is a very important resource in the wireless environment, so here we opt for the selective retransmission. That is, RFC 2018 allows for the acknowledgements of single packets, not only acknowledgements of in-sequence packet streams without gaps. Sender can now retransmit only the missing packets. Advantage, much higher efficiency in terms of the bandwidth, but the disadvantage is more complex software in a receiver, more buffer is required at the receiving end. Transaction-oriented TCP or the T-TCP protocol. In this case, we are having TCP phases. That is connection setup, data transmission and connection release. And basically, we are aware that this is a three-way handshake. and it needs 3 packets for setup and release respectively. Thus, even a short message, even we want to send a 1 byte, it need a minimum of 7 packets in this case. So the transaction oriented TCP or the T-TCP, it says it is known by the RFC 1644. It says it describes a TCP version to avoid this overhead. Connection setup, data transfer and connection release can be combined into one. Thus, only 2 or 3 packets are needed. That is, in this case, if we go for the 3-way handshake, then we are having TCP. MN will send a TCP sync packet to the CN. It will send the acknowledgement to the MN, and once it receives the acknowledgement, connection setup will happen. Then data transmission phase. These are the packets flowing for the data transmission, and for the connection release, we require again these packets, that is TCP finished and TCP fin or acknowledgement from the CN side. And once the MN sends the last TCP acknowledgement to the CN, then the connection release is confirmed. So in the case of the T-TCP, we have combined the packets for connection establishment. Now here, with the SYN packet, along with SYN packet, we are sending the data information. Once the CN, it receives this packet, it will send the connection packet related to connection release, that is TCP acknowledgement finish packet. And once the MN, it sends the TCP acknowledgement to the CN node, the connection will release. So the connection release with user data packet, this can reduce the number of packets down to 2 instead of 7. The obvious advantage for certain applications is the reduction in the overhead which is standard TCP has for connection setup and connection release. Now this particular table, it shows the comparison of different approaches for mobile TCP. In the case of the indirect TCP, the mechanism which we have seen is it splits the TCP connection into 2 connections. Advantages is as a isolation of wireless link, and it is simple in nature, but the disadvantage, loss of TCP semantics, higher latency at the handover. In the case of the snooping TCP, we have seen that it snoops the data and the acknowledgement packets, and it will do the local retransmission. What are the advantages? Transparent for end-to-end connection, MAC integration is possible in this case, but it shows the problems with the encryption because it is snooping the data. So it is playing with the security. Bad isolation of wireless link. In the case of AMTCP, it splits the TCP connection and it chokes sender via window size. It maintains end-to-end semantics, handles long-term and frequent disconnections, but a bad isolation of wireless link, processing overhead due to bandwidth management. Fast retransmit or fast recovery, it avoids the slow start after roaming. It is quite simple and efficient, mixed layers and disadvantages, mixed layers, and it is not transparent. In the case of transmission or timeout freezing modification, or approach, it freezes the TCP state at disconnect and resumes after reconnection. It is independent of the content or encryption and it works for longer interrupts, but changes in TCP is required at the wireless environment because it is MAC dependent. In the case of the selective retransmission, it is retransmitting only the lost data, and that is why it is very efficient, but the disadvantage is slightly more complex receiver software, complex receiver software is required and more buffer is needed. Whereas in the case of the last approach, that is transaction oriented TCP, it combines connection setup or release and data transmission into 2. Efficient for certain applications, but the changes in TCP is required and it is also not transparent in nature. These are the references which I used while preparing these slides. Thank you. And this is all about the modifications we have done in the TCP so that it could be adapted to the wireless environment. Thank you.